In this video, we briefly demonstrate the usage of the interaction and visualization techniques proposed in our work, titled A Visual Interaction Framework for Dimensionality Reduction-Based Data Exploration. Let's suppose I have a multidimensional dataset containing 8 different indices of socioeconomic development for 34 countries around the world. To better visualize and understand the structure of the data, a common method consists in applying a dimensionality reduction algorithm, such as PCA, to reduce the number of dimensions to 2, so that our countries can be represented as a bidimensional scatter plot. In the projection view, the distance between the data points tries to preserve their difference in the multidimensional space, so that similar countries are close to each other in the projection. However, this application of PCA leaves us with some unanswered questions. What do the axes of the projection mean, and how do they relate to the original data dimensions? Why a point is in a specific position of the projection plane, and what determines its distance from the other data points? To address these issues, we introduce a set of techniques to enhance dimensionality reduction-based data exploration. The first interaction technique we introduce is called forward projection. The idea is that I first select a data point, I modify its feature values in the multidimensional space, and then I observe how its position gets updated in the projection plane. For instance, here I can increase the value of student skills of Turkey, observing how its projection moves rapidly towards the central cluster containing the European countries. Instead, if I try to change the value of life satisfaction, I notice that the point doesn't move much, indicating that this feature is not influential in determining the position of points in the plane. We introduce a new visualization, which we call ProLines, to visualize in advance possible forward projection paths. A ProLine is generated for each feature, and its length represents the relevance of a feature to a particular projection. Each ProLine also encodes distributional information about the feature, such as the current value, the mean, standard deviation, maximum, and minimum of its distribution. Wouldn't it be easier to simply drag the point instead of manually modifying its feature values? For this reason, we introduce the backward projection interaction. I select the data point, I modify its position in the projection space, and then I observe how its feature values are modified. We introduce the possibility to define equality and inequality constraints for backward projection, so that we can keep certain values constant or within a desired range. For instance, I can modify all values but educational attainment, or put an upper bound on the development of Turkey in student skills. We introduce the feasibility map visualization to visualize in advance which regions of the plane would be able to satisfy user-defined constraints. Until now, we showed the application of our techniques to a linear dimensionality reduction technique. But what about nonlinear methods? We present now a few examples involving autoencoder-based dimensionality reductions on 3 image datasets: NIST, QuickDraw, and FashionNIST. In this first example, we can observe how an image can be treated as an array of feature values, or pixels, which generate an equal number of nonlinear ProLines. Forward projection, which consists in modifying these feature values, can be associated to the action of drawing or erasing pixels. Through backward projection, we can notice instead how we can explore the pixel changes that a data point would have to make in order to move in a different region of the projection space. Through these examples, our techniques demonstrate to be useful for analyzing the behavior of the dimensionality reduction, in this case based on an autoencoder network, by introducing a change to the input of the model, in the case of forward projection, or by enforcing a desired output, in the case of backward projection.